Experiment 9 is a very practical lab where we'll be learning the basics of laboratory waste disposal. And it will be consolidating many of the topics that we've covered in the course. And this can include content, and it'll also include technical skills. In terms of safety, we'll be working with test reagents for a number of qualitative tests, and we'll be working with an unknown sample. And between the test reagents and the unknown samples, many of the chemicals that we'll be using you've seen before and have found safety information for before. So you can look back at the earlier qualitative labs and pH labs and these kinds of things to find that safety information. And we'll be using a couple of new chemicals, and you'll be looking up the safety information for those as part of your PreLab assignment. So the procedure that we'll be using to identify the components of our waste and then safely dispose of those wastes are going to be developed as part of the online lab session. And the next week, we'll be using those procedures in the lab. So before you come to the online session, it's worthwhile to review the qualitative testing experiments, the pH experiment, and the extraction of caffeine experiments. And the actual procedures that we'll be following are going to be based on the skills that you learned in those experiments. So when you're disposing of a chemical waste, there are a number of core guidelines that you should be following. The first is that you need to dispose of your chemical waste in accordance with federal, provincial, and municipal regulations. And these can be really difficult to find. And so for that reason, we're going to be working on general principles in this experiment rather than on specific details. So the individual who generates a waste is responsible for proper disposal of that waste. And for these reasons, you should always follow the 3 R's. So these are reduce, reuse, and recycle. So you should always minimize the amount of material that you're working with, so you should reduce the amount of chemical waste that you're generating. And ideally, you want to reuse or recycle the material if possible. Sometimes, though, you're not able to use the material over again, and you have to dispose of it. Now, the easiest way to do that is to simply pay somebody to get rid of the waste for you, but it's extremely expensive to do that, so we're going to look at ways to either do it ourselves or to reduce the expense if you have to contract somebody in. One of the guidelines for waste disposal is separation. You always want to separate your wastes into different streams. You want a stream for solid wastes or liquid wastes or organic or non-organic wastes. You want to simplify things down to as few different chemicals as possible. And because of this, you may have to perform a number of separation techniques. Certainly if there are multiple layers, say an immiscible organic and aqueous layer, you can separate them physically either by decanting or using a separatory funnel or something like that. Once you've separated your wastes as much as possible in-house, you can occasionally do what is known as physical treatment of that waste. So physical treatments are some physical manipulation of the waste to prevent them from contaminating either people or the environment or what have you. One way that you can do this is by sequestering or encasing the chemicals inside something like cement or concrete so that they're physically blocked from leaching into the environment. Another method that you can use to deal with wastes is chemical treatment. So chemical treatments are going to involve a reaction, and that's going to convert the waste into a less harmful material. So these methods can be neutralizing, like you would use for acids and bases. Sometimes you can burn a chemical, so combustion. This is often used for hydrocarbon-based products. Oxidation is common, and precipitation of something like a heavy metal into a solid that can be filtered off is another common way of treating chemicals. One of the final guidelines that we'll be talking about is the idea of volume reduction. So if you have to pay a disposal company to get rid of a chemical waste for you, it's often done on a by volume basis, which means that if you can reduce the volume, you can reduce your disposal expenses. So especially if you have something that's aqueous, if you can boil off or otherwise evaporate some of that water, you'll reduce the volume and you'll reduce the expense of getting rid of that chemical. So in this lab, we're given an unknown that has this label. There might be silver, there might be ammonia, there might be silver nitrate, there might be probably not ammonia nitrate, presumably ammonium. There may or may not be formaldehyde, chloroform, or cyclohexane. There might be potassium nitrate. There might be brine, which is something that you may or may not have to look up to identify. So when you're thinking about how to deal with this, which you should do before the online lab, is you should consider, are we likely to encounter a mixed unknown sample? And in this case, it looks like there might be a lot of things in this container, so it looks like your sample may or may not be a mixed sample. And you might want to think about some ways of identifying if your sample is a pure compound, a solution of a single compound, or if it is in fact a mixed sample. If you do have a mixed sample, you should be thinking about ways that you can separate it and isolate it down into as many separate individual chemicals as possible so that they can be treated more safely, or at the very least, you can reduce the volume of some of them. And you also want to be thinking about how you might treat each of the different chemicals on this label if you determine that they're present or absent. So if they're present, how might you treat them? And because you're first year students, you probably don't have a great idea of the chemical treatments that are possible. So one thing that you might want to use is something like the Merck index that we've linked to in previous videos and referred to in your lab manual. The Merck index gives you an idea of what each chemical is used for and some of the more common hazards or issues associated with them. Effectively like an encyclopedia entry for each of these different chemicals. You may also wish to refer to something like a hazardous chemical waste treatment guide. And I've included at the end of this video a number of waste treatment processes for some of the chemicals that are listed on this label. And the treatment guidelines that are shown at the end are from the book Hazardous Laboratory Chemicals Disposal by Margaret Ann Armour, who was a Canadian chemist. And the final thing you should be thinking about is if there are chemicals that we either can't find a treatment method for, or that we know cannot be treated in the facilities that we have available, how do we dispose of those untreated wastes?